On to example 2 of finding both the first and the second derivative using implicit differentiation. So again, the method with all of this is very simple. You first find the derivative with respect to y, with respect to x, just as what we did in the last 300 examples. Maybe not that many, but you get the point. We want to, once we find that, the dy dx, then we're going to derive what we got a second time using implicit differentiation, and then substitute in our dy dx. So that's the general strategy here. So strategy, first find dy dx using the methods that we've used above. Derive, actually I'd say derive both sides. Again, implicitly. And then what we're going to do is plug in the y prime we found earlier, or the dy dx we found earlier. That's the general strategy with this. Okay, so let's use this strategy to handle this example. First, put some parentheses around all of our y's, and let's go to town. Derive the first thing. So deriving that, power rule. Bring the 2 down, subtract 1 from the exponent, multiply by the derivative of the inside, which is, you'll just see. So we have 2y to the first times the derivative of the inside, which is y prime. Okay, then you remove all the extraneous stuff. We don't need the parentheses or the power of 1 anymore. Okay, now what we're going to do is find the derivative of the second term. This is also going to be a chain rule thing. So the inside function is going to be the exponent, which is y, and the outside function is going to be e to the x, or e to the y in this case. So what you're going to do is you write e to the y, then you multiply by the derivative of the exponent, which in this case is y prime. So that handles the second term. Now on the right-hand side, we need to derive this using the product rule because we have two functions in x being multiplied together. So handling this, derive the first one. So you get 1 times the second, without changing it, plus leave the first alone, and then derive the second. The derivative of y is y prime. Okay? So we've correctly implicitly derived all of this stuff. Now what we need to do is get our y prime by itself. So all of the y prime stuff we're going to move to the left-hand side. All of the non-y prime stuff we're going to keep on the right-hand side. So our y prime stuff is here, here, and here. That we all want on the left-hand side. So let's subtract over this lovely thing so that these cancel. And we subtract, the x, y prime from both sides. So rewriting, we have 2y, y prime, minus e, y, y prime, minus x, y prime is equal to y. 1 times y is just y. And then, that's basically it. We have all of this is equal to y. Okay, final step of finding just the first derivative. Well, second to last step, I always get that confused for some reason, is we're going to factor out our y prime. So you have a y prime times 2y minus e to the y minus x. And that's equal to y. Now, the final step of just the first derivative is divide both sides by this box. So this gives you y prime is equal to y over 2y minus e to the y minus x. Okay, so that's the first derivative. That gives us dy dx. Now we need to find the second derivative. So what we're going to do is derive both sides implicitly again. This becomes a little bit more tricky because we have a lot of y stuff to worry about, unlike the last problem. So this is still going to require the quotient rule to derive the right-hand side because we have this numerator of y, and we have the denominator with all this y and x stuff in it. So we'll have to derive these things using the quotient rule. So on the left-hand side, this is easy to derive. The derivative of y prime is y double prime. So we write y double prime, which is the same thing, by the way, as d squared y over dx squared. All right. So deriving this using the quotient rule, we derive the top, which is going to be y prime, multiply by leaving the denominator alone. So we have 2y minus e to the y minus x. And then we subtract when we leave the numerator alone, and then multiply by the derivative of the denominator. So this is going to require a little bit of effort here to do this denominator derivative. So we're now deriving 2y. That derivative is 2y prime. Now we need to derive the second term, minus e to the y. Using the chain rule, that gives you e to the y times y prime, just as like what we did in the last part of this problem. And then finally, you can subtract off 1 because the derivative of x is 1. Okay, are we done yet? Nope. We have to square the denominator. So we have 2y minus e to the y minus x quantity squared. All right, so we've successfully derived this right-hand side implicitly using the quotient rule. But we're not quite done yet because we have a lot of y prime stuff floating around here. We do not need to solve for y prime, but rather all we need to do to find the second derivative is take the y prime stuff that we have, this thing, and then substitute it in for our y primes. Right there. Okay, so every place you see y prime, replace it with this green function. Yes, it's going to get messy, but you'll live. It'll be okay, I promise. And by the way, things might cancel out too. So, at least in the first case, it will. Rewriting this. So with this lovely substitution, I like to keep things in boxes when they're big. 2y minus e to the y minus x times this yellow function here. 2y minus e to the y minus x minus y times 2, now time for another box, y e to the 2, y over 2y minus e to the y minus x. Put this in a bigger set of parentheses. Minus, oh boy, I'm running out of space, aren't I? All right. So I'm going to put this minus sign here in the denominator. This is getting really messy, but this will happen. So you have minus e to the y times this box again. 2y minus e to the y minus x inside this box, and then minus 1. So this is all inside this big set of parentheses here. So all we did was replace our y primes with this box. All right, we're not quite done yet because this entire thing needs to be put over the denominator that we had originally. So we just handled substituting in for our y primes. Now we just need to divide by this lovely thing squared. So what I'm going to do is put a big box around the entire numerator and then put this over the denominator squared. And then that's the final answer. If you like, you can cancel a few things out here and there. Namely, you can cancel this and this because they are the same, leaving you with just a y in the first term. But that's basically all the simplification that you can do. This is a very messy problem, but the moral remains the exact same no matter how you do these. So let's review the steps. What did we do here? So the strategy, first find dy dx using the standard implicit differentiation method. Then you derive both sides again implicitly. The left-hand side, if that's where your y prime is going to just turn into y double prime. The right-hand side is going to be a nasty mess, usually involving the quotient rule. Then the final step is once you find your y double prime, you're going to plug in the dy dx that you found in the previous part of the problem into your d squared y dx squared, your second derivative. When you do that, you'll have a function in y and x only. Notice the final answer here does not have a single y prime in it, does not have any double primes in it, it's just x's and y's. So using this method, it allows you to solve for the second derivative as well. If you wanted, you could keep finding derivatives. Like if you wanted to find the third or fourth or fifth derivative, you can keep doing this. It just becomes nastier and nastier and nastier. Okay, so that's problem number 2.